Okay, welcome back to Mr. Lamb's Science Corner. As I told you in the video before, we're now shooting at Mazama High School, where it's my old stomping grounds for 31 years. And we're doing this because some of the stuff, our demos, this one happened, the demo before was a commercially bought product. This one happens to be homemade, more or less, but it's here and it's not at home. So anyway, we're talking about now about water surface tension. And surface tension is caused by the kind of molecule that water is. If you want to know the details, water is a polar molecule, and you can Google for that and it can tell you far more than you want to know about polar molecules and how that sets up surface tension. But basically it forms kind of a skim on the water, and if you've ever done a belly flop into a swimming pool, you know exactly what surface tension is. And there's going to be several demonstrations that you can do with surface tension. We're going to do one of them today. By the way, there is a thorough misconception, you hear it lots of times, that if you're diving into water from a high height, it's just like diving into concrete. Well, that is wrong. It's just flat out wrong. I could use examples of people diving off the 10-meter board in competition in the Olympics. That's 33 feet, and they seem to go into the water pretty well. I could mention Mythbusters. They did a whole hour on this, and they took a pig carcass and they loaded it up with sensors and whatnot, and they dropped it literally from a helicopter onto concrete and into the water, and there was a marked difference between the two. Neither one would you, if you were in the place of the pig, would you enjoy it, but it was certainly more survivable falling in the water. And the reason for that is that when you or a pig or whatever comes down and hits concrete, you are stopped very, very quickly. And you're going to have the same amount of force, whether you hit water or you hit concrete or hit soft earth or whatever you hit. It's going to be the same amount of force because that depends on your mass and how fast you're traveling, which has nothing to do with the surface you hit on. What makes the difference is the time in which you're having the collision. If you hit concrete, you stop very quickly. The shorter the time, the higher the G-force when you stop. If you can cause it to spend a little bit of time, this is why cars are designed to crumple. Because you could build a car very, very rigid, and you hit something and you're going to die because you're going to be the one to crumple. If the car crumples, it takes time, and that's going to extend the time out which happens, and that makes the force less. And if you hit water, you're going to go down into the water. You're not going to go down into the concrete. I'm sorry, you're not. You're going to hit the concrete, you're going to go splat. And when you hit the water, you go down into the water. That means you slow down over some period of time. You're not going to enjoy it. I was reading Reader's Digest one time, years and years and years ago, and they talked about a guy in World War II who was basically shot down. His plane was on fire. He jumped out, and his parachute didn't work. And so he's screaming all the way down from about 10,000 feet, but he landed less than a mile away from a destroyer, and they heard him. And they saw the splash, they went over. They happened to have a doctor on board, which is unusual World War II with the destroyer, but they did, and he'd ruptured his spleen. If there hadn't been a doctor to do the surgery, he would have died, but they removed his spleen, and he lived happily ever after. I don't know if he ever jumped out of a plane again, like President George Herbert Walker Bush did, but I don't know, that's the rest of the story. But he survived the splash, and he fell from 10,000 feet. Okay, so surface tension. I'm going to pour some water straight out of the tap. And then I'm going to pour it into this very cleverly constructed water bottle with a piece of screening, metal or plastic, doesn't matter, and then a rubber band to hold it in place. So I just bought some screening, had the rubber bands, had the bottle. And I do this to show you that the water pours right easily through the screen. Okay, until it overflows. And then I always like to hold on to it because as you tilt it, there will be some inevitable water running. And you can see that this holding place. Now, you might ask, well, did I palm a piece of plastic or something like that on there? And the answer is no, and I can show you that because the water will flow out. So that is demo 1 for surface tension. Thank you and goodbye.